Hello. In today's video, we'll be seeing about deriving the various values of sine theta, cos theta, etc. for various values of the angle. For example, we'll be seeing how to derive sine 90, cos 30, etc. So first, we'll deal with sine 0. Fine. So this is a triangle we were talking about in the first part. If you have not seen the first part of the video, please go and see trigonometry part 1. Now, first we have to derive the relations for theta is equal to 0 degree. So when theta is equal to 0, this is theta, right? As it becomes 0, it becomes smaller and smaller and smaller till it almost reaches the third side almost reaches the second side. That is the hypotenuse, right? This hypotenuse, the small part is called opposite, and this is the adjacent. So when theta becomes 0, opposite becomes 0 and adjacent will become equal to hypotenuse. Either you can reason it out this time in this sense, that is, as theta becomes 0, the hypotenuse settles on adjacent, or you can use Pythagoras theorem. For example, h square is equal to a square plus o square, and now since O is equal to 0 when theta is equal to 0, h square is equal to a square plus 0 square. So h square is equal to a square, or h is equal to a. Plus or minus a actually, but since distances are measured only in positive direction, h is equal to a. Positive a. Fine. Okay. Now, so now in all of these substitutions, sine is equal to opposite by hypotenuse. Now, for sine 0, sine theta is equal to opposite by hypotenuse, right? So, for sine 0, it becomes opposite. Instead of hypotenuse, I am going to write uh, opposite by hypotenuse, and opposite is equal to 0 in sine 0. So, opposite is equal to 0, right? So opposite is equal to 0 by hypotenuse equal to 0. Now cos theta is equal to adjacent by hypotenuse, right? So cos 0 degree is equal, making use of this assumption, h is equal to a. So I am going to write h is equal to a by a equal to 1. So tan 0 degree is equal to sine theta by cos theta equal to 0 by 1 equal to 0. So cosec 0 is equal to 1 by sine equal to 1 by 0 equal to infinity. Sec 0 is equal to 1 by cos 0 equal to 1 by 1 equal to 1. So cot 0 is equal to 1 by tan 0 equal to 1 by 0 equal to infinity. So these are the various values. This table represents the basic trigonometric ratios for 0 degree. Fine, just a minute. Okay. So if you want, you can pause it and you can make note of it. Fine. Okay. I'll just pause it for 10 seconds, and so you may pause it and take a snapshot. You can take a snapshot, right? Wait. These are the values of the degrees for 0. Fine. Okay. Now we are going to take it for theta is equal to 30 degree. So for theta is equal to 30 degree, let's take a equilateral triangle. Fine. And drop a perpendicular, and this angle is 60 degree, and this angle is 30 degree. This is also another 30 degree. Together they make up 60 degree, and this third angle is 60 degree. Now I'm going to take let me name it as ABCD. I'm going to take triangle ABC, but I'm going to invert it. Like so, this is hypotenuse, this is opposite, this is adjacent, right? So this 30 degree and I'm going to invert it. So this is A, B, C, right? So I'm going to invert this triangle as, so this is 30 degree. So this is A, this is 90 degree. So this is C, and this is will be B, right? I have inverted the triangle. Inverted means shifting it. Fine. Okay. Now in this triangle, we know the side AB, right, is AB. Let's say it has a length A, right? BC has to be A by 2, because we are this is a AC is a perpendicular bisect. It's a perpendicular line which divides BD into two parts. So A by 2. So by we know AC by taking Pythagoras theorem. AC square plus BC square is equal to AB square. So this becomes AC is A square, sorry, AC we don't know, right? AC square, we are going to find it out. Plus A by 2 whole square equal to AB square, which is A square. So AC square is equal to A square minus A square by 4, which is equal to 4A square minus A square by 4, which is equal to 3A square by 4. This is AC square, which means AC will give root of 3A square by 4, which is equal to root 3 by 2A. So this is AC's value. As usual, we know it's actually plus or minus root 3 by 2, but only positive we are going to take because it's a distance. So AC is equal to root 3 by 2 A. Root 3 by 2 A. Fine. So AC is equal to root 3 by 2A. This is root 3 by 2A, and this is BC is A by 2, and then what else? This is A. Now sine theta will be equal to BC by AB. BC by AB. So sine 30. Now theta is equal to 30 degrees. So BC will be A by 2 by hypotenuse A equal to 1 by 2. This is sine 30. Similarly, cos 30 equal to AC by AB, which is equal to root 3 by 2A by A, which is equal to root 3 by 2. Tan 30 degree equal to sine 30 by cos 30, which is equal to 1 by 2 by root 3 by 2 equal to 1 by root 3. Okay. So and then sec 30 is equal to 1 by sine 30 equal to 2. Cosec 30 is equal to 1 by cos, I'm shifting down a little, cos 30 equal to 2 by root 3. Cot 30 is equal to 1 by tan 30 equal to root 3. So these are the trigonometric ratios for 30 degree. So if you want, you can copy the triangle, copy this, pause this, take a screenshot, and you can proceed with that. Fine. Next will be 60 degree. Now we'll be using the same triangle. So take a good look at this triangle, the third one. Take a look at this triangle, and we'll copy the same triangle here. Okay. Okay. So the same triangle I'm drawing, A, C, B. This is 30 degree, and this was 90, right? Now we know three angles of a triangle will be 180 degree. find sum of three angles of a triangle will be 180 degree. So theta plus 30 degree plus angle C is 90 degree equal to 180 degree. So theta is equal to 180 degree minus 120 degree. Theta is equal to 60 degree. Now once again I'm going to flip this triangle. Flip this triangle so that theta becomes here. Right? So this is now this A, this is C and this is B. Right, angle B is 30 degree and this is 60 degree. Now we try draw for 60 degree, we draw the triangle once again. Right, it's a equilateral triangle ABCD. Fine, and this is 60 degree. So I'm going to take, this is 90 degree, right? So I'm going to take this triangle alone and then I'm going to draw it like this. Fine, A C B. This is 60 degree. We know BC is equal to A by 2 since it's a perpendicular bisector. AC is equal to A. The side of the equilateral triangle is equal to A. Now, as we know, this AC will be equal to root 3 by 2 A. The proof have been derived in the previous session using hypotenuse Pythagoras theorem. But if you want, we can also derive it here. Okay, AC square plus BC square is equal to AB square. So AC square we don't know and BC square we know is A by 2 whole square is equal to AB square, which is A square. So AC square is equal to A square minus A square by 4, which is equal to 4A square minus A square by 4, which becomes 3A square by 4. AC square. So AC will be equal to plus or minus root 3 by 2A. But since distance is measured only in positive, AC is equal to plus root 3 by 2A. Right? Okay, fine. So we have derived it. Sine 60, as we know, is AC by AB, which is equal to root 3 by 2A by A, which is equal to root 3 by 2. Cos 60 is equal to BC by AB, which is equal to A by 2 by A, which is equal to 1 by 2. Tan 60 is very simple. Sin 60 by cos 60, which is equal to root 3 by 2 divided by 1 by 2, which is equal to root 3. So similarly, the other things follow. Cosec is equal to 1 by sin 60, right? Which is equal to 2 by root 3. Sec 60 is equal to 1 by cos 60 equal to 2. Now, finally, it is cot, right? Cot 60 is equal to 1 by tan 60 equal to 1 by root 3. So, you can take a snapshot of this derivation and you can use it. So, finally, next thing we'll be deriving it for 45 degrees. Fine. Now you have to take a right angled isosceles triangle for 45 degree. The meaning why it should be isosceles is any right triangle which is 45 degrees will have equal angle. This will also be 45 because sum of three angles of a triangle should be 180. So these two angles are equal. So by similarity of triangles, which you would have learned in 10th standard, these two sides must be equal, right? And this side we don't know, ABC, right? AC we don't know, we have to compute. So I'm drawing this once again. A, B, C, A and A we know. We have to find AC. Now AC square is equal to BC square plus AB square, which is equal to A by 2. Oh, A, right? Okay. A square plus A square, which is equal to 2A square. AC is equal to 2A square. AC square is equal to 2A square. AC is equal to plus or minus 2 root 2, right? Root 2A. Since we are using distance, AC is equal to root 2A. Fine. So this is root 2A. I'm going to use only 45 degrees here. Fine. So what is sine 45? Sine 45 is equal to AB by AC, which is equal to 1 by root 2. Cos 45 equal to BC by AC, which is equal to once again root 2 A by A root 2, which is equal to 1 by root 2. Fine. For this, if you have not understood AB by AC, then we have to write AB by root 2A, which is also equal to 1 by root 2. Fine. Tan 45 degree is equal to sine 45 degree by cos 45 degree, which is equal to 1 by root 2 by 1 by root 2. They both cancel and becomes 1. Similarly, I'm writing here cosec 45 degree is equal to 1 by sine 45 degree equal to root 2. Sec 45 degree is equal to 1 by cos 45 degree equal to 1 by 1 by root 2 equal to root 2. Tan 45 degree is equal to 1 by, cot, right? Cot 45 degree is equal to 1 by tan 45 degree equal to 1. So these are the ratios for 45 degree. If you want to take a snapshot, then do it. This is the proof. Fine. Okay. Now, finally, for 90 degree, we have to take it. Now, for 90 degree, this is theta, right? Now, as we did for 0 degree, we have to do the opposite. Instead of theta becoming smaller and smaller, theta will become now larger and larger. For example, if theta is equal to 30 degree, this will become 60 degree. Then this will become 70 degree. Theta is growing, right? So as it becomes 70 degree, finally, when it becomes 90 degree, right, this theta is equal to 80 degree. As theta becomes larger, it coincides with the opposite, right? Opposite, hypotenuse and adjacent. Now, as theta becomes 90 degree, what happens is hypotenuse becomes equal to opposite. Fine, this is the main thing. See, this is hypotenuse, this is opposite. As theta becomes greater and greater, when it becomes 90, opposite will become equal to hypotenuse and adjacent will become 0. See, this is not 0, this is opposite. Adjacent will be equal to 0. So, two things, hypotenuse is equal to opposite and adjacent will become 0. So, now sine 0, now this name is A, B, C. Fine. Okay. Sine 90 degree will be equal to opposite by hypotenuse equal to opposite by opposite equal to 1. So sine 90 is 1. Cos 90 will be equal to adjacent by hypotenuse, which is equal to 0 by hypotenuse equal to 0. Tan 90 will be equal to sine 90 by cos 90, 1 by 0, which will become infinity. Now cosec 90 will be equal to 1 by sine 90 will be equal to 1 by 1 equal to 1. Sec 90 degree, which will be 1 by cos 90 degree, which is equal to 1 by 0, is equal to infinity. Tan 90 degree will be equal to 1 by cot, right? Cot 90 degree will be equal to 1 by tan 90 degree, 1 by 0 is equal to infinity. So this will be the derivations for 90 degree. Take a snapshot of this if you require, then we'll proceed. Fine. Finally, I'm going to make a table, and this table will be I'll give you a mnemonic. Mnemonic means a memory technique where you can learn to memorize the values. Now let this be equal to theta. We start theta with 0 degree. This column, right, will be equal to 30 degree. Sorry, 0 degree, 30 degree, 60 degree, 45 in the middle, and 90 degree. This version will be equal to sine, cos, tan, cosec, sec, and cot. We are going to make a tabular column, and we'll write the various values. So in order to memorize these values, you need to remember only one line and derive it this. Wait. If you first draw a tabular column like this, and you are going to memorize it using a single value for this tabular column. If you memorize this one value, the rest of it can be derived. Fine. Sine 0, 0, 1 by 2, 40, 1 by root 2, 60 is root 3 by 2, and 1. So you just have to remember 0, 1 by 2, 1 by root 2, 1 by root 2, root 3 by 2, and 1. Fine. Remember this, the first tabular column value. For cos, you have to write it in the reverse. If you have to, I'm writing in the reverse means from here I'm going here. So it will be equal to 1 root 3 by 2, and then 1 by root 2, and then 1 by 2 and 0. Sine, you have to remember this. Fine. Cos, write it in the reverse. Tan is very simple. You have to divide the first column with the second column. So 0 by 1 is 0. 1 by root 2 by 1 by divided by root 3 by 2 is 1 by root 3. This is 1. 1 by root 2 by 1 by root 2 is 1. Root 3 by 2 divided by 1 by 2 is root 3. 1 by 0 is infinity. For tan, first column you have to divide it by second column. Fine. Okay. This is the These are the things. Fine. For cosec, right, you have to divide 1 by sine. 1 by sine. So 1 by 0 will be infinity. You have to just invert it. Fine. This will be 1 by 2 if you invert it. 1 by 2, you have to invert it. So 1 by 2 will become 2. Similarly, root 2, 2 by root 3, 1 by 0 will become, 0 by 1 is 0. 0 by 1 is 0. And this will become, oh wait, my bad, I'm sorry. 1 by 0 is infinity, right? So 1 by 0 is infinity. 1 by 1 will be 1. Fine. I've written right. Okay. For sec, you have to invert cos. The second column you have to invert. 1 by 1 is 1. 1 by root 3 by 2 is 2 by root 3. 1 by root 2 is root 2. 1 by 2 is 2. And 1 by 0 is infinity. Now you can see, if you are deriving it for cosec, then sec, for let me write the value for cosec. Cosec is infinity, 2 root 2, 2 by root 3, and 1, right? You have to write in for sec, you have to write it in reverse. That is 1, 2 by root 3, root 2 to infinity. Same as we did for the sine and cos. So it's more than enough if you write, remember, only sine, then cos is the reverse of it, tan is you have to divide it, right? For cosec you have to once again derive it from sine, but for sec you have to write the reverse of cosec. Okay, for cot, right, you have to divide it once again. So 1 by tan is cot, so 1 by 0 is infinity, and this will become 1 by root 3 will become root 3, 1, 1 by root 3, 1 by infinity. Many of you will be having lots of doubts regarding infinity. Infinity is a large number. For example, 1 by 100 is 0.01. So 1 by 1000 is equal to 0.001. Similarly, 1 by 10,000 will be 0.0001. So as the number becomes greater and greater, when it becomes infinity, it will become 0.000 till very large number where it will become 1. It is approximated, so 1 by infinity can be approximated as 0. Since effectively 1 by infinity will become 0.000, it will go on till here and become 1. So we can approximate 1 by infinity as 0. So cot of 1 by infinity will become 0. Right? Okay. So this is the table, and if you want, you can write it. See, for even for cot, there is a memory technique. You have to write the reverse of tan. See, tan, right, is equal to 0, 1 by root 3, 1, root 3, infinity, right? You write the reverse for cot. Cot will be infinity, root 3, 1, 1 by root 3, 0. Fine. So once again, I'm using only the memory technique. I'll be deriving the table. If you want, you can take a snapshot of this. So to simplify this, we'll be 0 theta is equal to 0, 30, 45, 60, 90. Sine, cos, tan, cosec, sec, cot. Right? This is the tabular column. You have to remember only the first line. Only the first line you need to remember, and that will be equal to 0, 1 by 2, 1 by root 2, root 3 by 2, 1. Remember just this first line. Cos will be reverse. Okay. Okay. So in today's video, we'll be seeing how to remember a mnemonic from which we can derive the tabular column for the various value of the angle. So see, sine 0, 1 by 2, 1 by root 2, root 3 by 2, and 1. This is the only value which you have to remember. Cos is the reverse of this. That is, starting from 90, you have to go to 0. So this will become 1, root 3 by 2, 1 by root 2, 1 by 2, and 0. See, I have started from 90 and I have gone to 0. Fine, this is 1 by root 3 by 2, right? So instead of going from this, I have written the reverse. Tan, you have to divide first column divided by 7 column. So 0 by 1 equal to 0. Similarly, 1 by root 3, 1, root 3, and infinity. Cosec, right? Cosec, we have to derive it just 1 by sine. So 1 by 0 equal to infinity, 2, root 2, 2 by root 3, and 1. For sec, you have to reverse. Sec is equal to reverse of cosec. So 1, 2 by root 3, root 2, 2 and infinity. Cot is equal to reverse of tan, right? And cos is equal to reverse of sine. Cot is equal to reverse of tan, that is infinity root 3, 1, 1 by root 3 and 0. So remember these three, you have to compute only, you have to compute first, you have to remember sine theta you have to remember, cos is equal to reverse of sine, and then tan is equal to sine by cos. Then cosec you have to compute only these three. Cosec is equal to, you have to 1 by sine, and then sec is equal to reverse of cosec, cot is equal to reverse of tan. So these are the things you have to compute, and these are the things you use the reverse. Fine. Okay. So this is, if you want, you can take a snapshot, and then we'll proceed to the third part.